Hello. Continuing our work in patterns, we're going to be looking at geometric sequences. So this is where we are going to be multiplying to get between our terms in our series or our sequence instead of adding like we were before. So if we look at the formula that we've got here, again, it's on page 22 in our log tables. If we see anything to do with patterns, 22 in our log tables gets opened immediately. So our general term this time, or our nth term this time, is going to be given by some constant a multiplied by or to the power of n minus 1. So a slightly more complicated looking formula, but we'll get used to it. A still means what it always did. It means the first term in our pattern. Or is now the thing that connects our terms together. It's the common ratio. So just like before d was our common difference, it was the difference between each term. The common ratio is what we multiply each term by to get to the next term. And it's given by Tn divided by Tn minus 1. So any term divided by the last term, so 6 divided by 3, or 12 divided by 6, or 24 divided by 12, would be the common ratio. So it's the number that we multiply a term by to get to the next term, just like the common difference was the number we added to a term to get to the next term. So what's our common ratio this time? Well, we can view it in our list here. How do I get from 3 to 6? If I can recognize that I'm not adding something on. So my first instinct would be just add 3, but that doesn't work because I can't add 3 again. I don't end up at 9, I end up at 12. What am I doing to get between each of these terms? I'm multiplying by 2. So instead of adding something, I am now multiplying to get between my two terms. So I'm multiplying by 2 each time. The other way we could find that, so if we were asked for the nth term of this pattern, if I was asked for Tn for this pattern, I'd write down my formula and I'd be looking for A. Still means the same thing as A always did. It's the first term is 3. And or I can get from my list by figuring it out, or if I can recognize I have a geometric pattern, I can also use the fact that I could divide any of my two terms. So 24 divided by 12 should give me my common ratio of 2, or could just as easily be 6 divided by 3, which also gives me 2. So just like d would be any two consecutive numbers subtracted from each other, any two consecutive numbers dividing each other will give me my common ratio of or. And this is a defining characteristic of a geometric series, that their common ratio must be the same for any two consecutive numbers in my list, any two consecutive terms. And that will come in for more advanced type questions, as it did for common difference earlier on in the chapter. So now I have my A and my OR. Let's just sub it in here. So my Tn would be equal to 3 multiplied by OR is 2 to the power of n minus 1. Now, every now and again, you're going to see a notation called dot notation or dot product, which isn't technically on your course, but from time to time gets written down anyway. So I'm going to make you aware of it. That's where they put a big dot in between 3 and 2 to mean multiply. So the dot, in this case, a big dot in the middle between two numbers means multiply. It's not technically on your course. I'm pointing it out because you will sometimes see it. So it's important that you know what it means. So if you see a funny dot between two numbers, it means they're multiplied together. 3 is multiplied by 2 to the power of n minus 1. So the power is only on the 2, is the significance of that. But we don't see it too often. It's important for you to know that it's there. Let's do another one, because this is a little bit of a different pattern than we're used to. I'll give you another very straightforward example. If I have 3 over 2, and then 3 over 4, and then 3 over 8, that pattern keeps going. Let's find out what Tn is equal to. So if I'm asked for Tn, I'm going to write down the Tn formula, and I'm looking for A. A is just equal to 3 over 2, and OR is equal to any of my two consecutive numbers divided by each other. So my third term divided by my second term is what I've chosen this time. If I'm dividing by a fraction, I invert the fraction and multiply, or get the reciprocal of the fraction and multiply. And again, important to note, if I got the second term divided by the first term, I would also end up with a half as my common ratio. So now I know my common ratio in my first term. Tn is going to be equal to 3 over 2 is my first term, multiplied by a half, Tn minus 1, and that is my general term, or my nth term. So let's work out a slightly more complicated question now. If I'm told that the third term in a geometric sequence is 6, and the 8th term is equal to 1458, what is the nth term? So if I'm told that this is a geometric series, or it could be called an exponential, geometric sequence, or a exponential sequence would be another way of saying it. If I'm told that, how am I going to find it out? Well, I know I'm looking for Tn's involving a geometric sequence, so I'm immediately going to write down that formula and then see if I'm able to use it for anything. Well, I'm told about T3 and T8, so let's write down T3 and T8 and see if we can make any progress with them. So T3 is going to be equal to A on or to the power of 3 minus 1. And I'm told that that's equal to 6. So A to the power of 2, A multiplied by or to the power of 2 is equal to 6. And T8 would be A multiplied by or to the power of 8 minus 1 is equal to 1458. A to the power A multiplied by or to the power of 7 is equal to 1458. And now I want to try and find out what A and or are. So I look at my two equations and see, how can I get rid of something? Well, I could do a substitution, but there is actually a faster way to do it. So I could do a substitution, and this is a perfectly good way of solving this problem. All I'm looking for is the value of A and or. Currently I have two equations with two unknowns, so I'm going to do some variant of a simultaneous equation. So I could get A by itself and sub in to this equation here, do a substitution, and I'll get an equation only involving or. That's a perfectly good way to do it. A slightly faster way to do it is to recognize that you could have my second equation divided by my first equation. We'll have the A's cancelling out. So I can do it that way as well. But if you wanted to do a substitution where you rearrange this to be A is equal to 6 all over or squared, and sub that into this equation to find an equation only involving or, you'll get full marks for doing so. But it's often a little bit easier to just divide the second equation by the first one. So that's what I'm going to do here. Or to the power of 7. So if I have equation 2 divided by equation 1, A to the power of 2, 6, and dividing one equation by the other, I can see that the A's cancel out. A to the power of 1 divided by A to the power of 1 is just 1. So I'll be left with or to the power of 7 divided by or to the power of 2. Subtract the powers and I end up with or to the power of 7 minus 2. 1458 divided by 6 is 243. Or to the power of 5 is equal to 243. And now I need to take the fifth root of both sides. So we're not terribly used to doing this. When we do more algebra later on, we'll get a little bit more comfortable with taking larger roots than just square roots or cube roots. So you will be a little bit more familiar with this later on. That should be a 5. I'm taking the fifth root to get rid of a power of 5. That's a fifth root on our calculators. So OR is going to be equal to 3. So OR is equal to 3. Now I want to find my missing A value and my value for Tn. That's what I'm looking for. So I've now got the OR I need. I now need to get the A. So I can use either of these equations here to find my value for A, because I know that A multiplied by OR squared is equal to 6. So this is T3. Just to remind you, T3 we found was A is equal to by OR squared is equal to 6. And I know that OR is equal to 3. So A on 3 squared is equal to 6. At 9A is equal to 6. Dividing both sides by 9. Get A is equal to 2 over 3. So then Tn is going to be A on OR to the n minus 1. Tn is equal to 2 over 3 on 3 to the power of n minus 1. And that is my nth term for this pattern. So critically, if we're given this in an exam, if I recognize I've got a exponential or a geometric sequence, I'm going to write down my term for that type of sequence, and I'm going to try and sub into it. And when I sub into it, I'll often be able to see a way that I can start eliminating letters, either by substitution or by other form of simultaneous equation, and thereby get one of my letters, and by substitution get the other letters, and get my nth term. But I get there by recognizing that I have a particular type of sequence, so I write down the formula for that type of sequence, and by subbing in what I'm given in the question, I'll almost always be able to make progress. So that's what we need for the beginning of geometric sequences.